So hi everyone, today I'll be showing you how to create a shape button in JUCE. A shape button is basically any button that's defined by a path, for example, a rectangle, a triangle, or an ellipse, a circle, and so on. So today we'll be creating a shape button and attach that button to MIDI data, and that MIDI is converted into sound. So yeah, so let's have a go. I'll just quickly open JUCE. I'll create a new JUCE project called shape button lesson. Then open. I'll just quickly run it to make sure everything's working fine. Cool. So I'll just select standalone at the top to make sure my standalone plugin's working. Cool. That looks good. So let's start off by going to the plugin editor.h. Then over here you say JUCE shape button, and then maybe just call it shape button. And then we go to plugin editor.cpp, and basically the shape button has an overloaded constructor. So if we look at let's say shape button JUCE, and if you see the documentation, shape button has a parameterized constructor with the string name, color, overcolor, and downcolor, right? So we need to create an object with the same constructor signature. So let's put a comma here, and then let's say shape button, and within that we can just call it maybe shape button, and then let's say JUCE colors red, and then we can say JUCE colors black, and then we can say JUCE colors green. Cool. Now the next thing is actually setting the shape, right? So we need to declare a button size. So let's say float button size equals 50.0f. Then we can create a new path called button path or button shape. So JUCE path, say button shape. And over here, I mean, this is where we can actually add something to the path. Like we can either add a rectangle or a circle or anything that we would like. So let's say button shape dot add, let's say rectangle. So how do we define a rectangle? Let's say 0, 0, and then let's say button size and button size. So if you note that this 0 and 0 is respect to the position of the button. So suppose the button is positioned in the center of the screen, you wouldn't really, I mean, you can't, so it's still 0 with respect to the button itself. So suppose the button's on the top, it's still 0 with respect to the top. I think that'll become clearer when I actually set the button position. And so let's add a rectangle, and then below that we can just set the shape. So shape button dot set shape, and within that you say button shape. And then what does it say? Resize now fit to this shape. We can say true. Then maintain shape proportions, let's say true. And then we can put the shadow for false at the moment. Then let's add and make it visible. Within that we say shape button. And yeah, let's check if this works for the moment. I misspelled true. That looks good. So we have a rectangle over here. So initially it's red, and when I go over it, it becomes black, and when I click it, it becomes green, right? So we can change these colors over here. We can just change red to anything else, black to anything else, and so on. Cool. So let's set the position. As I mentioned, right, 0 and 0 is respect to the position of the button. So we need to set the position of the button over here. So let's say shape button dot set top left position. Okay, let's say we want to set it to the center. So let's say get width by 2 and get height by 2. Let's run it and see what happens. You see, now the top left is in the center. Cool. So we can just get rid of this hello world for now. And so what's the next thing? So we can see that our button's working. Let's try and change this maybe button to an ellipse, right? So let's say button shape dot add ellipse. Then again say 0 button size and then button size. So you see it's an ellipse over here. It's basically a circle, right? Because the width and the height is equal. Cool. So we have a circle there. Now, what's the next thing? The next thing is we need to make it work like a button. So let's create a new listener. Say public JUCE button listener. So I'll just quickly check the documentation. JUCE button listener. So button listener reference. So you see, this is a pure virtual function. So we need to definitely override this. So I'll just quickly copy this and then just paste it. I don't need the virtual keyword. And call this override. Then let's change this to JUCE button. And we can call this button here. Semicolon at the end, and let's copy this. We need to define this function, right? So we've declared it. And let's just copy the class name and remove this override and actually define it. So let's check if it's actually working. So let's say JUCE logger dot write to log, say button clicked. And before that, we also need to add a listener. So what we say is shape button dot add listener and then say this. And let's see how this works. So I click this, I get a notification here, it says button clicked. So each time I click it, it's basically clicking. So that's good, it's working. So now we need to connect this to MIDI, right? So how do we connect this to MIDI? The first thing is we need to create a MIDI collector object. So we go to the plugin processor.h. So until now, we've been working with the plugin editor. So the plugin processor.h, we would basically say JUCE So MIDI message collector, then say then we also need to create a synthesizer, and that would be JUCE synthesizer, and then say synth. So then we'll be loading an audio file over here, so to test if the synth is working. So let's create a format manager as well. So JUCE audio format manager, and then say format manager. Cool, that looks good. And let's go to the constructor to actually initialize these objects. So let's start off by saying format manager dot register basic formats. Now we need to add voices, right? We need to add voices to our synthesizer. So we have a JUCE synthesizer object and we want to add voices to it. So let's say synth add voice, and then say new JUCE sampler voice. And let's add 5 voices in future. If you want to increase the number of voices, so I less than 5, and I plus plus. Basically added 5 voices, right, to the synthesizer object. Now the next one is to load sounds. Now I don't have any sound file yet, so what I would do is I would just quickly go to free sound, and over here I would just say C guitar. So in case you don't have an account in C sound, you'll have to create one first. Then let's just find C#.wave. That sounds cool, I think. So let's click here and download it. Basically, I would find that in my downloads. I go to the Finder, I go to downloads. Then, which one is it? That's good. So I just say get info. I would just copy the path. And I just paste it here for the moment. And also I need to add the file name. Cool. So just load this as a comment for the moment. Cool. So let's first dot clear sounds. Now we need to add the sounds, right? So let's say JUCE file sound sample. Then we just need to paste our path, right? So let's copy this, paste it here, and put a semicolon at the end. And then we just need to, let's create a big integer. So JUCE big integer, and then 0 to 128, and then say true. Then let's actually add the sound, synth.add sound. And then let's create a new sampler sound. So JUCE sampler sound. And let's give it a name. Let's just call it maybe guitar. Then we need to attach this to an audio reader, right? So there's something I missed out over here. So after creating a sound sample, a file object, let's create an audio reader. So let's say standard unique pointer, then say JUCE audio format reader, say audio reader off, and then say format manager dot create reader for, and let's just add our file object, which is called sound sample. Oh yeah, forgot to create. So the name of the big integer is all nodes, and then say all nodes dot set range. That's 0 to 128, and then comma true. Cool. So let's add a sound, and then so we dereference the audio reader pointer here, and then let's say all nodes. Now the root MIDI node. So what's the root MIDI node of C#? Let's quickly have a look. Say C#. Okay, let's say MIDI node mapping. So I think C3, I think it's a guitar, right? So it would be C3 mostly. So C3 48, C# would be 49. So let's just say 49, which is the root node. And then attack time, let's just say 0.01 for the moment. Release time, and then maximum sample length. Let's just put 10 seconds for the moment. Doesn't matter. Cool. So we've added a sound, right? Now the next thing is to process the MIDI. So we need to initialize the MIDI message collector object. So let's go to prepare to play. It's a function that's called before the playback, right? So let's say synth dot set current playback sampling rate. Let's say sample rate here. And also say MIDI message collector dot reset, then say sample rate. Cool. And that's done. We need to actually process this MIDI data next. So let's go to the process block. And here say MIDI message collector dot remove next block of messages, say MIDI messages, and then say buffer dot get num samples. Then we need to synthesize, like we need to pass this MIDI data into the synthesizer. So let's say auto audio bus buffer equals get bus buffer. Let's say audio bus buffer, then MIDI messages, and 0. Okay, this was a different constructor. I want to add 2 more parameters, and then audio bus buffer dot get num samples. Then we need to actually render next block. So synth render next block, then say audio bus buffer MIDI messages 0, then say audio bus buffer dot get num get num samples. Cool, there's something wrong here. What's that? Oh, I'm sorry, guys. Made a mistake here. So basically buffer, false, and then 0. So the thing is, right now our MIDI pipeline is kind of working. We've set it up for the audio processor. The next thing is to actually connect the audio processor with the editor, right? So how do we do that? So we need to return the MIDI message collector to the editor so that it can be controlled. So let's create a new function, say JUCE MIDI message collector, then say ampersand get MIDI message collector. Let's call this no except. Then return MIDI message collector. So you see this MIDI message collector. So I'm basically returning this object here. Now let's go to the editor. Okay, there's something wrong. I'm sorry. Cool. Don't need this one here, sorry. So we're basically returning the MIDI message collector into the plugin editor. So we want to, so each time a button is clicked, we want to play the sound, right? So let's kind of modify this to such that if I press the button, the audio would start. And then when I remove the button, the audio would stop. So let's change. We need to add another event handler, right? So we look at button listener. There's something called button state changed. So a button click is basically a mouse down and a mouse up. So the click is finished only when the mouse is up. So we don't want to look at clicks. We want to look at button state change, right? So let's override another function here. So let's say void button state changed, and then say button override. And let's just add JUCE before this. That's done. We copy this and we need to define the function. Add the class name before. Cool. So let's just comment this out so that we don't have to see it printing button clicked each time. Let's say JUCE logger dot get current logger. Okay, we just don't need that. We can just write to log, then say standard to string, and then say button get state. Yeah. And then let's just say button state. And let's just run it and see. Let's just observe the behavior. So we enter this button state 1, go out button state 0, go in button state 1, and then we click it button state 2, and I release my mouse button state 1, and then I remove this button state 0, right? Cool. So the thing is, button state 1 occurs 2 times. So when I enter the mouse, when I enter the button, I don't want a note off to occur that time, right? Obviously, I want the note off to occur only when I move from a mouse down to a mouse up. Cool. So let's just create another variable, say int previous button state. And then we can just set this to 0 in our initializer list. Then go down over here. Let's say previous button state equals button get state. We wouldn't be using this immediately. Let it just stay there for the moment. So where were we before this with the MIDI collector object? We wrote a function over here that would return the MIDI message collector. And so the thing is, if button get state equals to, what we would do is audio processor dot get MIDI message collector dot add message to queue. Now, how do we add this message? I'll quickly go to JUCE tutorial. And over here, there's an example of how to handle MIDI data. So create MIDI data. You go down, you would find this. So let's just copy this for the moment. And say auto message equals note on. A note number, let's just say 49, which is the root note that we set. And I think this is, okay, what's wrong? MIDI channel. You can set the MIDI channel to be 0. And then okay, wait, there's so we've created this. So I think this is the velocity over here. So let's just check JUCE MIDI message note on. Note on, that's yeah, in channel, int note number, and then float velocity. So we're just typecasting it to the velocity that's from 0 to 127. So let's just set the velocity to be 100. And then so we're getting high resolution counter into 0.001 because it's in milliseconds. Let's just set the start time to be 0. And we need to add message to queue, right? So let's add message to queue and put the message over here. Just remove this line. Let's just run and see what happens now. Okay, there's something wrong. Channel should be greater than 0. So I think I need to set the channel to 1. So plugin editor.cpp. Yeah, I'm sorry, guys. It should be set to 1. For some reason, it's indexing from 1 in this case, not 0. I think MIDI's starting from 1. So let's see that. So I click. Now I don't get a note off yet. So the sound's coming each time I click. Cool. So here's where our previous button state is helpful. So let's just cut this here and put this down here. Then let's say if else if get button state equals 1 and button, let's say previous button state equals 2. So the previous button state is equal to 2, then this should trigger a note off. So let's just say note off. Let's try if this works. Cool. So I think this is where I'll end the tutorial, and I hope it was helpful. Thank you.